In this lesson, we're going to continue to examine how we can evaluate logarithms. We're going to go backwards and forwards between logarithmic form, exponential form. Sometimes one is easier than the other, depending on what you need to examine. Okay, so quick reminder from yesterday, exponential form is where we write a base to an exponent, comes out to an answer. The same question in logarithmic form, the base to the exponent comes out to the answer, if you will. The trick here is that remember we have to figure out what the exponent is that makes that answer, right? Okay, 6 squared is 36, or 6 squared is 36. Okay, so exponential form, we have exponent. Logarithmic form, you have a log, obviously. Let's go look at some examples here. I want to rewrite these in their opposite form. So we have to recognize what form do we have, how do we rewrite it. So this is exponential form, the first one. And my base is 4. 4 to the 3 is 64. So I write it this way. 4 to the 3 is 64. And when in logarithmic form, back to exponential form, so 5 to the 4 is 625. Okay. Same thing for here, 2 to the negative 6. We know negative exponents make fractions. Right. And then the last one, the log, my base is 729. Anyway, 81 comes from 2/3. 729 to the 2/3 is 81. Fractional exponents make things smaller. Negative exponents make fractions, and then obviously regular exponents make bigger numbers. Okay, when we're evaluating, so not rewriting, but actually calculating, we have to think to ourselves, a to the power of what makes m? Okay, so let's try and do some of these without using our calculators, get in the habit of not having to use your calculator. Then when we do need to use it, we only need to use it for ones that we're not so sure about. So first one here, 2 to the what makes 32. 2 to the 5. 3 to the what makes 729. Maybe that's a pretty big one. Maybe you need your calculator. Guess and check. Should go to 6. 9 to the what makes 3. I want to recognize that my base got smaller. And actually, if I recognize that the square root of 9 is 3, I might say to myself it's a half. And I know that because I know fractional things make things smaller. D could be confusing, so I might rewrite this just to think to myself, okay, that's what I really have. I'm thinking 6 to the what makes 6 to the 1/4. Well, if these are the same, then these are the same. So my answer has to be 1/4. Log 8, root 8. Well, again, if I rewrite that, log 8, 8 to the half. Oh, 8 to the what makes 8 to the half? Oh, just a half. And I can combine some operations here. Log 2, 16. 2 to the 4 is 16. 3 to the what is 27. Well, that's 3. Comes out to 1. And yet, this is not something I put in my calculator, right? So I do need to know these ideas about how to evaluate if I want to get down to that answer. 4 to the what makes 64. Well, that's 4. 7 to the what makes 0. Well, if I want to make a 0, I know that, sorry, I want to make a 1, I know that my exponent has to always be a 0. Okay? Anything to the power of 0 always comes out to 1. This answer is just 4. Okay, so those are the kind of things we were doing yesterday. There's nothing new there. We just makes a little bit more practice. Okay? Using these two forms, exponential and logarithmic, we can actually solve a whole bunch of different questions that involve exponents. So I'm going to look at some examples here. And sometimes they're in a good format, sometimes they're not in a good format. We may have to play with it a little bit. I just really need to think. In this first one here, what I'm really thinking is 4 to the power of 4 equals x. Well, 4 to the 4 is something I just type in my calculator. That's 256. Hey, x is 256. Okay, exponential form, which is what this is, actually makes it easier to figure out. Logarithmic form is not really good. If I try the next one, I get x to the 4 equals 81. That's exponential form again. And we actually know how to solve bases with exponents on them, we take nth roots. This is a 4, so I want to take the 4th root of 81, type in my calculator. Hey, x is 3. Okay, now theoretically it could be a plus or minus 3, but we know we can't have negative bases, so we never worry with the negative one when we're doing the nth root of a logarithm. Try the last one here. 9 to the power of negative 1/2 is x. That's good. I got x by itself. Negative exponents means I want to flip my base. And a 9 to the half is like a square root, so x is 1/3. Okay, so by taking things that were in logarithmic form and turning them into exponential form, we actually made these questions easier to solve. Okay. The one time, and I said yesterday that we can't really use our calculator, but there is one time we can. We can if we have a base of 10. Okay, so if you were to see log 10 of something, that's something you can put in your calculator. Any other time you cannot. Our calculator is only programmed for one base. If you don't see a base, you just see something like, oh, log, oops, not log, so that's what log. You just see log of, I don't know, 26. The 10 is assumed. It's not shown, but if there's no base shown, we assume there's a little 10 right there. That's kind of our standard notation. So if you come across something like letter A here, log of 1,000, there's no 10 showing, we know it's a 10, that's our standard base. These are things you can use your calculator with. Type in log 1,000, you should get 3. You can also do this and get decimal, that's fine. Log 25, 1.39794, dot, 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 dot. You can do small numbers, log of 0.01, comes up to -2. And it's smaller than 10, right? It's a fraction of a tenth, which is why you have a negative exponent there. And anytime you come across base 10 or no base, calculator is a good tool. I can combine that with our previous ideas and solve some things. And look at part A here. I want to find log of something equals 3. Well, I know it's a 10 even though it's not showing, which means I could write it as a exponential form and type it in my calculator. X is 1,000. Same thing for this one, part B. I can say 10 to the x is 5. Ooh, that makes it more complicated though, right? I could have, at the very beginning, just typed in log 5. Log 5 is something my calculator can do. Just calculate that. And I get 0.6989 dot 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 is x. Yes, this is a situation where I wouldn't want to put it into exponential form because I have something I can already calculate. Third one, I can't calculate because I don't have a base. I have to go to exponential form. Oh, but if I can find my x by cube rooting 125, I'll get 5. Okay, so we're going to play with these different forms, but forwards and back between exponential, logarithmic, depending on the situation, you have to think a little bit. I'm going to finish this off with a word problem today. Here we got fog. Fog can reduce the intensity of headlights. The distance of an oncoming car whose headlights have an intensity of I lumens is given by this equation. How far away is a car whose headlight intensity is 50? You know, 50 is my lumens, it's my I. So in part A, you're just going to plug in the value that I've been given. 50 over 125. It's a base 10 because it's not showing a number. You can type that in your calculator the way it is. Make sure you put the log part in brackets. And if you do, you should get 66.46 meters. In part B, if the intensity doubles, does this mean the car is half as far away? Well, if the intensity doubles, our intensity was 50, right? Now we're going to go to 100 lumens. Let's see how far away the car is now. Okay, so exact same expression, double intensity, our distance is c.1. So it doesn't mean it's half as far away. In fact, it looks like it's almost a quarter of the distance. Okay, so the answer to the question was, does it mean the car is half as far away? No. No, the car is much closer than half the distance. In fact, it's almost a quarter, right? And that's how logarithmic scales work. Okay? They're not going up by a linear amount, and they're going up by exponential amount, right, like that. So it's the distance maybe was here, and now it's here, but the height is much further. Okay, that's the end of evaluating some logarithms, just getting used to the different formats, going back and forward. For all the questions 1 to 6, just do A, C, and E those for the applicable questions. If they don't have an E, don't do it, obviously. And then tomorrow we'll move on to some more things we can do with logarithms, where we have more expressions, if you will.